Hello there guys, and welcome back to another epic inexorable maths video. In this video we're taking a look at how we can calculate I to the power of n for any integer n. So any whole number, positive, negative, 0, I to the power of that basically. I to the power of any integer, where I is the square root of -1, so I is the imaginary unit. Okay, how do we do this? Well, you can notice something, it's quite easy to see this. If you just keep timesing I by itself, you get this pattern emerge. So this is, I'll just zoom in here, this is the pattern. You start off with our number I, the square root of -1. You times I by itself, you square it basically, I times I. I times I by definition, because it is the square root of -1, gives you -1, okay? It's basically the square root of -1 squared. Cool, which is obviously -1. So, -1, you times that by I again, -1 times I, that's going to give you -I. Checks out. -I times I, that's going to give you -1, which is going to give you +1. There we go, we've got +1 chilling out right there. And finally, 1 times I again gives you I, because it's 1 times I. So this is like sort of I to the 1, I squared, I cubed, I to the 4, I to the 5. But you can go around again, I to the 6, I to the 7, I to the 8, I to the 9. And you can see it goes on and on and on and on forever. It's really, really convenient and nice. So what this means, and also by the way, if you want negative powers of I, so let's say I to the power of -45, you just go backwards. You just divide by I. It's going to give you I to the -1. You divide by I, it's going to give you I to the -2, and so on and so on and so on and so on and so on. So yeah, well this is actually going to be I to the 0, and then this is going to be I to the -1, and so on. But you get the idea, okay? You just go backwards, basically. Cool. So let's actually have a crack at a question here. So what you want to do, and actually before we have a crack at a question, we're going to have a look at why we can do what we're about to do. So I'm going to say, for example, let's say we want to find the value of I to the power of, and let's actually use a number here. We'll say I to the power of 67. I to the 67. What is that equal to? Well, it's a bit difficult to work out. But what we can do is we can try to get a multiple of 4 out of the number 67 and see what is remaining. The reason why we're going to do this is because I to the power of 4 is equal to 1. So any multiple, in the power of 4 is going to give you the number 1, because you're just going around that many times. So 1 times 4, you've gone all the way around and you've got to 1 once. 2 times 4, that's obviously going to be 8. That's just going round twice. You're still at 1 though. So any multiple, any integer multiple of the number 4 is actually just going to give you 1. So this is equal to, we know what 67 is. We want to find the biggest multiple of 4 in 67. Well, that's going to be 64. It's 64. And of course, because 64 is a multiple of 4, but 64 is not equal to 67, so we still need to add our 3 on here. Hope that we can agree that 67, or I to the 67, is the same thing as I to the 64 plus 3. Okay, now we will write this as I to the 64 times I to the power of 3. You're allowed to do that because this is just index laws. Two things adding in the power equate to timesing the bases, basically. So we have this now here. But I to the 64 is 1. We know that it's 1 because it is a multiple of 4. Any multiple of 4 for I in the power-wise is going to give you the number 1. You can show this by writing I to the 64 as I to the power of 4 to the power of 16. Because 4 times 16 is 64. So this number here that we've got, this is I to the 64. And you times that again by I cubed. But it's very clear to see at this point, I to the 4 is equal to 1. That's really easy to work out. So it's 1 to the power of 16. So I to the 4 is equal to 1. So that means that 1 to the 16 is obviously equal to 1. So it's basically 1 times I cubed, isn't it? Which ends up with just I cubed on its own. I cubed is minus I. Just remember, basically, remember I squared, I cubed, I to the 4. And then that's all you need. So I to the 67 is actually just equal to minus I, which is very interesting. This is like, it's somewhat surprising, but it shouldn't be that surprising because there are other numbers that have that cyclical nature. You can raise them to any integer power you want and they'll just alternate between different numbers. -1 is another one. -1 will just alternate when you raise it to integer powers of -1 and 1, -1 and 1, so on. You can also do this for negative powers as well. You just need to be careful, because what you will end up with, and let's just quickly do an example. Let's find I to the power of, let's say, minus 90. Let's just do minus 90. So what is I to the power of minus 90? Well, I to the power of minus 90 is simply going to be equal to I to the power of, and what is the number minus 90? We can write that as minus, all negative, and what's the number 90? Well, the biggest multiple of 4 in 90 is going to be 88. So I to the 88, and then we're going to need to add 2. It's going to give us 90. Cool. And this is equal to I to the minus 88 times I squared. I to the minus 88 is, again, it's going to be equal to the number 1. So I to the minus 90 is just equal to I squared, which is equal to minus 1. If you do end up, sometimes you will do this, sometimes you will end up with like a 1 over I situation or something like that, or 1 over minus I. In order to get this back into your just normal sort of I minus I form, you can simply times the top and the bottom by I. This is totally legal because you're timesing by I divided by I. You're timesing by 1, so it's not changing the number when you do this, but what it does let you do is just times the numerator and denominator. So you get I over I squared, which is I divided by minus 1, which is minus I. So you get that 1 over I is actually just equal to negative I, and that would then be your answer from there. Cool. That's the gist behind it, guys. That is how you times I by itself, any integer number of times, to work out essentially any of those powers pretty easily. If you enjoyed this video, thank you so much for watching. Like, subscribe, share with your friends. I'll see you in the next video. Cheers.